About a year ago, I bought this 1994 Sonic the Hedgehog token roller cabinet. I began restoring it, mostly off camera. Actually capturing the work that I do is something that I've struggled with a lot, so I intend to get better at that, and hopefully you'll hold me to it. With that being said, I am now turning my attention more to this channel, and I anticipate to have more videos coming out at a much better rate. So, let me show you what I have planned today. This machine is fun to have friends play whenever they visit. However, I've nearly scolded at least one of them for doing too well. See, in its current state it dispenses tickets, which is neat. However, it doesn't just dispense them, it demands them. When it runs out of tickets, it locks up immediately and can only be corrected by either loading more tickets or power cycling it. And even power cycling it only gets you one more roll of a quarter before it locks up again if you didn't load more tickets. Even if they are cheap, I'm not interested in always having to buy more tickets just to play this thing. Also, the ticket dispenser is very noisy. Lastly, I haven't found anywhere that gives good prizes for them around here. Excuse me, ma'am. I have nine tickets. What can I get for 9 tickets? Is there something I can trade them in for? Like, do I get a prize? No? Okay, well, never mind then. But, Zelda, what can I get for these? Can I get anything for these? Link, quickly, what can I get for these? Anything? Can I redeem? Come on. So. Oh my goodness. Ooh. Oh, wait. I just want my tickets back. Ma'am, can I get my tickets, please? Look, you're not offering anything, okay? So, with that in mind, today I'll be seeing if I can convince this machine that it's still dispensing tickets when it absolutely isn't. The game knows when it's no longer successfully vending tickets. This means that not only is the game telling the dispenser to vend the tickets, and possibly even how many, but the dispenser is also indicating to the game whether or not it was able to. I need to figure out how this communication takes place, and through which wires. While it would be a solution for most of the issues to just be able to remove the game's ability to know that it's out of tickets, I'd really prefer to not have the dispenser run at all. The art of simulating something involves discovering how it works. With that being said, the best tip that I can offer to anyone looking to work on something this old is to try and find the documentation. I was extremely fortunate to have been given a copy of the service manual for this cabinet. Through it, I can look at the wiring diagrams, as well as the connection charts, and start to get an idea of what the 4 wires that run to the ticket dispenser do. From the manual, we're told that pin 1 goes to the CPU board, pin 2 is the ground pin, pin 4 is the 12 volt, and pin 7 is another logic line that travels to the CPU board. The remainder of the pins are unpopulated. So our main priority seems to be discovering what those 2 logic lines do. A tool that I've been sorely lacking in recent projects is an oscilloscope. While I still hope to save up for a high-end model eventually, I went ahead and purchased this cheap little FNIRSI 138 Pro off Amazon to test out for this project. Since I know which wires are the power and ground, thanks to the service manual, I should be able to use the ground to see what kind of signals are being sent or received and when they're being sent and received. To make checking the white wire easier, I decided to add some dangling wires to the points of the connector. Since my oscilloscope is hooked up now, I see a constant 5.5 volts. However, once the tickets start to move, there are periods of time relative to when the tickets are moving past the photodetector where the voltage drops. I was able to explore this further by leaving the machine turned on and just moving the tickets in and out of the sensor with my hand. Each time the sensor goes from block to unblock, there seems to be roughly a 0.1 to 0.2 second low pulse before it returns to 5 volts. So what about that gray wire? Well, while the signal is more noisy, there appears to be a half a volt being sent to that wire from the main board whenever the machine wants the ticket dispenser to be running. So the machine appears to be sending this signal until it sees enough pulses from the white wire to add up to a number of tickets that it wants to have dispensed. From here, my plan of attack is forming. My first question is, were I to just send the pulses that the white wire expects constantly, would the machine care that it looks like tickets are endlessly flowing? Or will it only be monitoring that while sending the trigger signal through the gray wire? Let's start with programming an Arduino to send 5 volts and then go low for a tenth of a second or two, and then continue that pattern indefinitely. As I've stated in previous videos, I'm not that great of a programmer, so for this I'll just actually be reusing the tiny bit of code that I wrote for my pedometer hacking video. And I'm even using the same Arduino Flora for the testing. Now to just hook this up to the wires that I placed on the ground and white wire connection points earlier. Also, this Arduino is happiest around 5 volts, and I don't think that it would survive the 12.4 volts that the ticket dispenser is supplying, so I'll give it power externally using a phone charger for now. Here goes. And success! Turns out that this is likely all we'll need to convince the main board that all is well when the ticket dispenser isn't even running. All that's left now is to package it better, to make it work off the power provided by the machine, and possibly to have a clean way to switch back and forth between ticket simulation and the actual ticket dispenser. After all, some would understandably be offended if I deleted the ticket dispenser altogether, and I may even be one of them. For a smaller Arduino, I purchased a SparkFun Micro Pro clone. Well, actually I purchased several. Now, to power it, 12.4 volts is too high. Typically, whenever trying to power something simple like an LED with too much voltage, you can just use Ohm's law to work out what size of a resistor would bring the voltage down to a preferred range. However, when the item that you're powering is something more complex, it may draw different amps at different times, which throws a wrench into just using a resistor, as the resistance would need to change as well to keep the voltage the same. So instead, I'll be using a buck converter. These are great if you have something with a higher DC voltage and you want to be able to constantly control what voltage a circuit will be provided, regardless of draw. I put some thought into how to have both the sim and the dispenser still function at different times. The answer is actually really simple. A single pole, dual throw switch would do the job. Full disclosure, I didn't have one of those on hand, and I didn't feel like waiting to ship such a simple part to me, so a double pole, double throw switch instead will be used, and I just used one side of it so that it works the same as a single pole. The important part of the switch is the double throw. That essentially makes it so that of the 3 pins we're using, 2 are always connected. So if I wire that 12.4 volts that the machine is providing to the center pin, the switch will decide if it either goes directly back out to the ticket dispenser, powering it on, or if it goes to our buck converter and then gets converted to a usable 5 volts. Better yet, it only does one or the other, so effectively we'll either be powering the simulator or the ticket dispenser, but never both at the same time. Sounds like we have our circuit planned out, so it's time to build. For the final board, I used some prototype board that I picked up years ago when Radio Shack was going out of business. It was just barely large enough to fit the Arduino, buck converter, switch, and some screw terminals to make everything clean. The buck converter didn't use standard hole spacing, so I used some stripped wire and made bendable legs that could work both as a standoff and their connection to the board. On the other side, I connected the power and ground from the buck converter's output to the Arduino. I decided to use digital pin 2 on the Arduino for the signal for no particular reason. Here's a quick layout of how everything's wired. Once it's all together, it looks better than I expected, and it's quite compact. That helped me to find a good mounting spot for the board, which I then proceeded to mount crooked to add authenticity. Time to test out the final board. So far, it seems to be working exactly as planned, and it really does help with the playability of this game. Now I can enjoy the quirky, nostalgic sounds and animations without having to worry about where I'll buy tickets from next. For my next mod on this machine, I plan to build some baffles inside so that rather than a large tray, I can have the quarters run into a small bucket for an easier time circling them back out for further play. Regardless, if you're subscribed, this won't be the last time you'll see this machine. And I also plan to do a video solely dedicated to its history, construction, and the steps that I'm taking to preserve it. Hopefully this inspires someone to try their hand at simple electronic mods like this for their very own favorite arcade devices. Just remember that any changes you make that aren't easily reversible will affect how future owners think about the machine. In this instance, I doubt I'll ever part with it, and if I did, these changes are fairly simple to remove. Anyway, thank you so much for watching.